Leetcode 973 k closest point to origin. So we are given an array of points represent like this: point I equals to xi comma yi. So return the k closest point to the origin. So the distance would be calculated as Euclidean distance, whose formula is given. Now let's see the example. The example here is 0.13 minus 2 2 and k is 1 here. So if we calculate 1 3 distance from 0, it would be 1 square plus c square, which is nothing but square root of 10 as the Euclidean distance, and for minus 2 2 it would be square root of 8. So square root of 8 is less than square root of 10, so minus 2 2 is closer to the origin. So our answer would be minus 2 2, because we have asked for k equals to 1, which is return the 1 closest point to the origin. Now let's try to understand this with the example. Since we have to return the k closest point to origin, we are thinking of something as a heap. So this is our formula, which is x2 minus x1 plus y2 minus y1 whole square. Here x1 and y1 are always 0 and 0. So we can simplify this formula to be x2 square plus y2 square root over. So we can simply use this as x2 square plus y2 square for simplicity. So if you calculate for different points, let's take this example. For 0 10, it would be 0 square plus 10 square, which is 100. For minus 1 minus 2, it will be 1 square minus 1 square plus minus 2 square, which is 5. Similarly for others, the distance are written here. Now here our k equals to 4. So we need to return the 4 closest point to the origin. So we'll be using an max heap here. How we'll be using here? Let's try to do it by the example. Given 100 first, we are at this 100. We added it to the max heap. Then another 5. We added to the max heap. The next 61. We added to the max heap. Since we are following the max heap property, we are not doing anything. Now 104. We added to the max heap, but here we are not following the max heap property. So we'll be simply replacing at this node. Now at this node we are not following the max heap property. The maximum should be at the root 1. So we'll be simply replacing. Now this follows our max heap property, and also our k size is 4. That is, whenever the k size is greater than, whenever the heap size is greater than k size, greater than k, so we will be removing one element from the heap, and after addition of the new element we'll be removing the maximum element from the heap. If we remove the maximum element, we will be left with the remaining closest k elements to the origin. So now the next point is 40. So we'll be adding this. This is following the max heap property. Since it is following the max heap property, but here we notice that our heap size is now 5 and our required is 4. So we'll be simply removing the maximum one. To remove the maximum one, we will be swapping this with the root, and we'll be simply deleting this. Now this, from the swap node, we will be ensuring the property of the max heap. So maximum would be 100 here, maximum of both the childs. So this is following property, this is also following property, so this is there. So at this point of time we have the 4 closest points to the origin till what we have scanned the input. Now 82 is inserted. Now we'll see if it is inserted. It is following the property we're inserting. No, it is not following since the root is smaller. So we'll be swapping this with root. Now in this way it is following the property. Now the 82 has been inserted here, but our size is 5, which is greater than 4, so we'll be removing the maximum one. Our maximum one is 100. To remove this, what we'll do, we'll swap with the last one and we'll be deleting the last one. Now we'll ensure the heap property. To ensure the heap property, it should be 40 here, 82 here. Now our heap property is ensured. Now we'll be moving to the next one, 49. Now we'll be adding this 49. Since it is not following the heap property, we'll be swapping this with 49 here, 40 here. Now it is following the heap property, but the size is 5, which is greater than 4, so we'll be removing the largest element here. To remove this largest element, we'll be swapping with the last one, which is this. We'll be deleting this, and to ensure heap property, we'll be giving it the maximum at the root. Now after 49, these all things are there. Now I'll be inserting 130. To insert 130, we'll be seeing, since we're not following the max heap property, we'll be swapping this. Be making this 130, and then we'll be swapping, since this root is also not following heap property, we'll be doing this 130, swapping this 61. Now it is following the heap property, but the problem here is our size is 5, which is greater than 4, so we'll be removing the maximum element. To remove the maximum element, we will swap this 130 with 49, and we'll be deleting this 130. Now we'll be maintaining the heap. The maximum of these two are 61, so 61 should be here, 49 should be here. Now this is in place, so we are following the heap property. Now we don't have any input here, so this is our k closest point. Let's output this, which is 61, 49. If we output this in the order, we will be getting the maximum one first, 40, then 5. This will be our output for 61. It is -5 -6. For 49, it is 7 0. For 40, it is -2 6, and for 5, it is -1 -2. So this should be our answer, and our output is same as our answer. Now what will be the time complexity? The time complexity would be, basically we are using this a heap where every insertion and deletion operation takes log of element present, log of the size of the heap, which is number of element, size of heap, which is number of element present in this heap. So now every time we are trying to maintain the k size, because if it is passing the k size, we are deleting it. So we are maintaining the log of k, and at max we will be doing for the n operation. So time complexity would be order of n log k. This is our time complexity for the problem. Let's try to understand the code. To understand the code, in Java we have priority queue to implement max heap. So we'll be initializing our priority queue, and in that we'll be passing the comparator. Our comparator would be storing in such an order where it would be representing the maximum one upward, which is b naught square plus b1 square minus a naught square plus a1 square. So this is a b point, this is a point, where we'll be comparing two elements there. We are giving the two size array to the input. Now what we'll be doing, we will be iterating through this points array one by one, and we'll be offering it to the priority queue, which is inserting it to the priority queue. Now if the size is greater than k, we'll be polling the maximum out, and then we'll be doing the same operation. So at last we will be left with the only k points which are there in the heap, which are closest to the origin. To fetch these k points, what we'll be doing, we'll be taking a two-dimensional answer array where its size would be max heap dot size, which is k in our case, and the dimensions are 2 because xi and yi are there. So we'll be emptying the heap out and be storing it into our answer, and we'll be simply returning our answer. Thank you.